Hello! Today we are going to try a big cut. This is my third cut. I have done three things here. One is I've taken a bitmap. Let me show you the bitmap. This is Sarah. She wants to be close to me. This is very cute. You want to come up, Sarah? Okay. Okay, sit right here. Say hello, Sarah.
Hello.
All right. So we've taken this bitmap. Let me take the... This is the bitmap that I originally found off the internet. And I made some vectors from it. Let's see. This one and this one. Those are the vectors I made from the bitmap, or from the JPEG actually. And then I also made a circle so that I can basically, let me show you what it should look like. Yeah, so this is the whole thing basically.
Let us try it here, Daddy.
Set preview.
Let us try, Daddy. Daddy.
Oh yeah? You are drawing. What are you drawing, sir? So this is what we're going to try to cut today. This test one, very long cut. I looked at the calculation for how long it should take. It says it should take nearly 10 hours. Goodness. So this is a test to see if my router can handle 10-hour worth of cut. Plus, we're looking at 1 bit but 3 passes. I'm still using the 1/8 inch end mill high-speed steel, and this is also a test to make sure that we can get a nice 3D, let me do the visualization one more time, a 3D cut. Last one wasn't sculpted at all. It was technically 3-dimensional, but this one should be pretty nice. And for dimensions, we're looking at from here over to here, it's 22 inches, and from here to here, it's 11 inches. And I'm going to be doing that in the middle of my workpiece. I've already set 0. And regarding the x-axis and how it tends to fault, I think it might have something to do with the... One moment, please. Come here. Daughter wants to be held right now, which is very cute. Good job. So the x-axis is faulting a little bit, and it is, I think, because of the coldness in the shop here, or in the garage. So I slowed down the acceleration and max velocity of the x-axis. Y and Z are totally fine. I think maybe it's the weight of the x-axis that's the issue. I wonder if the motor is a little bit undersized. No standing on the table.
Why?
Because I'm going to be working on the table. And I could perhaps make a different motor or change the voltage to it, but we'll worry about that. You want to go inside?
Yeah.
Okay. I'm going to take Sarah inside, and then I'll continue right after I get done. All right, here we are again, and I think it's about time to begin. Okay, so I've already taken the toolpath and I've imported it into K-Motion CNC. This is the program I have running the motion of the tool. We are rewound, our 0 has been set, and it's time to... Safety glasses. Ugh. Time to begin. Now for this cut, I have the whole thing, which is a 2 foot by 1 foot section, being cut just a little bit under the surface to hopefully hide this little error that I put there earlier. This is probably Well, this is definitely part of the reason why this cut is going to take so long. So I'm going to let it run for a little bit, then I'll come back and see how it's going. And in a while, maybe in an hour or so. So stay tuned. This has only been a couple minutes, but hopefully you can see where we're going here. Let me start up the vacuum. We're basically cutting the outline of the 2 foot by 1 foot section and doing a little of the profile as well. The part of the dish where the Seahawk logo will be cut. Pretty nice, even though we don't have a good bit. Now this is just a roughing pass, so this will be cleaned up when the finishing pass occurs. Hopefully, we shall see. See this move around a little bit as it crosses the path of the logo. This corresponds with the up and down of the spindle. Taking pretty light cuts, not very aggressive like the last one. I think I'm only going down like 0.1 inches. Looks pretty good so far. It's gonna take a while, but this is a test. I'm gonna test to see if it can cut for 10 hours straight, and well, see how the design turned out. I'll give you an update later. Just notice this. Take a look at the pulley. That's not running straight. That'll do some to wear out the belt. I'll have to talk to the builder about that. Doesn't look like the shaft is bent. Hopefully that's true. I have to take it off and see for myself. Coming along pretty good, I'd say. You see kind of the stair step path that it's taking. This is again using an 1/8" end mill. Not a ball nose, straight cut end mill. I decided to do the finished path this way, so hopefully that'll clean up the sagginess on the inside. Fairly pleased so far. Pretty good, not too loud. And oh, that's interesting. You see here, cut is much deeper here than it is here, as in it didn't cut at all. This tells me that my wood is either not level, which I would not like to believe, or the table itself is not level. We're going to have to do some calibration on the table to see how it sits front to back. Yeah, this looks pretty good. Pretty good. Curious. We'll figure it out. Okay, so the cut is done. I was using only one drill bit, or one end mill, the 1/8 inch end mill. I used 3 types of profiling. One we did a 3D raster cut, did a traditional roughing cut, and then we did a finish cut. Finish cut was done this way. My thinking was that the roughing this way and had large jagged edges on the slight curves would get fixed with the finish cuts. Let's take a look what happened. Don't know if you can see that. This has clearly got a stair step. This is supposed to be like a smooth dish, but it's not. This is a dish over here. This is okay. This is okay. And right around here, it's sort of this weird stair step. It's interesting. You can see the texture there. Focus. It is indicative of the width of the bit. It's okay. I should really be doing this with a 1/16 inch or smaller bit. And I'm sure I'll learn other techniques, different cutting methods. But I found the logo last night, created vectors, and created a toolpath. Oh, also, software said it was going to take 10 hours. It really took just over 7 hours. Still too long for what I got. So what did I learn? I learned that I can create a 3-dimensional path, which is good. See how this logo looks pretty badass, actually. Also learned that my table, or this cutting surface, isn't exactly level to the spindle or to the Y carriage. You can tell this because there's a little lip here, and there's no lip over here. There's nothing. The bit did not even touch. So if we can compare this side, this kind of goes away, and this side stays pretty good. It goes away about here. So it may be that the work surface itself was being held up or down, I guess. Maybe this side is up. Who knows? I'm certainly not holding it down properly. As you can see, my work holding is inadequate at best. Still, not too bad. Happy with it. Go Hawks. This is actually a better angle to see the smoothness of this side. Relative smoothness. I guess it would still require some sanding. And you can see where it's slightly lighter right here. It's almost as if this section, which clearly got the rough pass, did not get the smooth pass. And I wonder if the y-axis shifted a little bit. I wonder if it skipped. As if it were skipped a little bit to the right. I'll have to measure it out. Rough, smooth, and smooth. If it shifted to the right, this would have also gotten smooth. And I also see, which is slight, you can barely see it here. It's raised a little bit. Not sure why. Let's get little gouge marks here and here. This is also curious because I think these are in correlation with the depth of the actual passes, the 3D rastering cuts. So there's one pass at 0.1 inch. I guess there was this pass, but this 0.1, 0.2, this might be 0.2 and 0.3, and 0.4 is down in the middle of this thing, but that's the very bottom. So it's interesting that we have these arcs through here. I'll have to experiment with different cutting techniques. And even more importantly, actually get a ball end mill, because this is kind of silly to do curves with a straight cutting end mill. I don't know if you could see that. Focus. That's all there's to it. Very simple. Either way, not too bad. I'll have to wait to get some real end mills. Till next time, this is Jeremy. Bye-bye.